Welcome to Limitations of Science. This is the sixth installment. We're actually at the core of the overall subject matter. Tried to build up some background for you before we got to here. This particular topic is, what are the limits of science? Can science do everything given enough time or not? If you recall, as a way of introduction, the idea that science can answer all of our problems given enough time and enough money and putting enough brain power on a particular subject, that science, using the scientific method, will eventually be able to solve everything. It's just a matter of having the right tools and the right term. That idea is scientism, and it is a false idea. It is believed to be false by many of the people I've already quoted earlier when we talked about scientism. So let's kind of feather this out and examine the thing. Is it possible? Is scientism possibly true? And so what I want to do then is give you a list. There are others, but these are the ones. Some of these, I have to give credit where credit is due, and without blaming the person I'm giving credit to with believing everything that I believe. But the whole idea of enlisting the limitations of science came from Dr. Henson from Bob Jones University. He was my professor in undergraduate school in my biology major at Bob Jones. And then he put these in his textbooks. He wrote a series of high school textbooks and elementary school textbooks, but in the high school textbooks I used for a number of years. And he had a whole section on limitations of science. So the idea of it is his, at least that's where I got it. But I'm not using his list exactly, but some of them are the same. And so on the one hand, I want to give him credit for coming up with the idea. On the other hand, don't blame him for everything I'm saying here. So without further ado, let's begin. Okay, so when we talk about science, we talk about things that we can see or smell or taste. In other words, things that are made sensible to us. Science is limited to those things because you can't experiment on things you don't know exist. It's kind of obvious. But so hard science must deal with things that can be examined or demonstrated to the senses. Now, this limitation changes with technology. So, first of all, let's look at it this way. There are things that we know exist that we can't see. We could give numerous examples. X-rays were not visible, or we were not sensible to them. We have no way of detecting them with our body, yet we discovered them through film. I think it was the way that was discovered. Ultraviolet, it would damage us, but we didn't know because we couldn't see it. Infrared was discovered, interestingly enough. Somebody put a row of thermometers on the wall right next to each other, and then he projected a visible spectrum on the thermometers, and he let through a projector in a very, very dark room, and he noticed that the red light was warmer than the violet light on the other end, which is very, very curious, and that was an interesting thing to discover. However, what shocked the researcher was that beyond the red light, below it, where we could see nothing, it was even hotter, but we couldn't see it. And that was dubbed infrared, or below the red spectrum. And that was how we discovered that. Now, as it turns out, our body can detect infrared in the form of heat, but we didn't know that it was a type of light. Then on the other side, the ultraviolet, that was discovered when someone was photographing the spectrums. They were actually probably doing it for stars or something, but they were photographing the rainbows that are produced when white light goes through a prism. And they were taking pictures of them. And then they noticed that beyond the violet, the film was developing. And so he kept doing it over and over again. And sure enough, he marked it on there. And sure enough, when he developed a film beyond the violet that we could see, the film was developing. And so we called this ultraviolet, beyond the violet. So those are the first two kinds of light that we discovered. And what I want you to pay attention to is this limitation we're talking about. Until we were able to measure ultraviolet, or until we were able to measure infrared, we had to know it existed, even though our senses, in the case of ultraviolet, we have no way of detecting it. It can damage our skin, but we didn't see it. We couldn't see that it was there. It was doing it. Our skin can detect infrared, but we didn't know that it was a time of light. And as it turns out, the visible spectrum that we can see, the colors of the rainbow from red to violet, is actually only about 2% of all the wavelengths of light that exist. So if you had a complete spectrum all the way from radio waves up here to gamma rays and all the different wavelengths in between, light is in the center. We call it light because our eyes can see it, but there's only 2% of all the different kinds of light that actually exist in the universe. So the point here being is that until we were able to detect these, and each of them has a different way of detecting them, we couldn't study them and we couldn't know that they existed. The other example I give is a microscope. And so for thousands of years, we thought that if you had a fever and what we call a cold today, and in George Washington Day, they called it the ague, I believe, ague, so I'm not sure how they pronounced it. We treated people because the Greeks taught us that if you have the fever, you have too much blood. And so the standard treatment for about 1,600 years was to let some of the patient's blood out, and this would cure the patient. And we did this for about 1,600 years. And I want to tell you the story of George Washington, if you're not familiar with it, in case, I don't believe I've told you the story yet. But the story goes something like this. George Washington, the first president of the United States, is retired from the presidency, and he does what he's wanted to do all his life. He spends time on his beautiful home and his 3,000 acres. He has like 3 farms, 1,000 acres each, something like that. And he spends the day he gets up in the morning, eats breakfast, goes out on his horse, and spends the morning into lunchtime, a little past lunchtime, going from farm to farm, talking with his managers, and generally supervising the production of corn and grain and things of this nature. He started out with tobacco, but tobacco economy collapsed, and he switched to grain, at any rate, some combination of those things. So one fall morning, I don't remember the exact dates, he came back early to the house. His wife met him, and he said he had the ague. He had a congestion in his throat, and they put him to bed. And as the thing got worse and his breathing got more labored, his wife called the physician down in Fairfax, I would assume, and he rode the long trail out. They don't have phones, so he had guys to ride out on a horse, find the doctor, and then the doctor gets on a horse and rides back to Mount Vernon. And realizing that this could be fatal, because back then today we don't have a lot of people die from the viruses and colds and things of this nature. But back then the death rate was a lot higher. Anyway, they called the doctor. The doctor arrived, and he did what was prescribed, and that was he let some of the president's blood out. Now, the attending physician, kept very careful records, and he measured the amount of blood that came out, and also we have extremely careful records. He was aware that he was treating a very famous person, someone that was beloved by the nation, the first president, and he wanted to make sure he made a record for history of how, in case they lost the president, that he had a very careful record from history that he had done everything he could to try to save the president, to protect his reputation. And, out of genuine concern for the president. So he made a couple bloodlettings, and the condition began to get worse. He called another physician, sent a horse out, brought back another physician so that he wouldn't be the only one making decisions. They did a number of other bleedings, and eventually the president died. And this was a standard practice back then. That's all they knew. Now, you can criticize them, except the problem was a technological one. There was no way in that time period that they could ever have discovered what was causing the sickness. They couldn't have done it. There's no way they could do it. So they were operating on a theory. They were doing the best that they could, and they did this for 1,600 years. The reason is because these diseases are caused by microorganisms, and they didn't have a microscope. They didn't have a microscope at all. So, however, once the microscope was developed, and by the way, we had microscopes, but they weren't being produced. I'm pretty sure we had them for a couple hundred years, but they weren't being sold. They weren't using them for biological research. They were simply extant. I'll tell you the story of the microscope. It was invented by a Dutchman, I believe, Netherlands, I think. Although I get Denmark and Netherlands screwed up. I have friends, and they often criticize me. Anyway. He was actually a merchant selling fabric. He was selling silks, and he believed that the guy he was getting the silk cloth from was cheating, that he was taking 1 in 10 silk threads out, putting them over here, and inserting a wool thread, which was a lot cheaper. So when he was actually claiming that he was selling them 100% silk, he was actually selling them 9-to-1 threads, 9 silk, 1 wool. And so he said his motivation for making this microscope was that he wanted to know if this guy was cheating or not. I actually have a picture of the microscope right here. We still have the microscopes. They have them in the museum there. And it doesn't look anything like the microscope that you and I are familiar with. So right here you have a little ball lens, single lens microscope. You have a needle here with these various screws. The reason he needed that is because this thing was magnifying hundreds of times, and if you tried to move it manually, it magnifies it, so it moves like you just move it a tiny bit. And if you're looking through the lens, it's like a typical microscope. You look it through the lens, it's magnifying 100 times. If you move the slide just a tiny bit, it looks like it's zooming across the page. So he had to have these screws so he could move it just a little bit. And he would put a drop of pond water. And in the case of his initial reasoning, he wanted to see if could see wool threads mixed in with the silk threads. Now, I don't know if he found out the guy was cheating or not, but that was the cause of the invention of the microscope. What's interesting is this guy was very bright. He started looking, if you've ever looked at a microscope, you say, boy, that looks really cool. You look at your skin, it looks completely different. So he was that kind of guy. He was very curious. And he made a notebook, which we still have in the museum. I think they keep it with them, with the original microscope that you just saw. And as it turns out, he looked at pond water, spoiled soup, all kinds of things. And he wrote and he did drawings of what he saw in the lens. So once we developed this technology, then it became theoretically possible for us to connect viruses or even bacterial diseases with certain diseases. However, it was a very long time. It seems to me the microscope was sometime in the 1500s, and George Washington is the 1700s. And although somebody in the world knew that there were microorganisms out there, he called them little beasties. We call them microorganisms. Living things that are so small we can't see them. They were still killing us. So even though we were not aware of the existence of microorganisms, they were still having a huge effect on our lives. We also found that we were making cheese with them. We didn't know that there were microorganisms. All we knew that if you stuck nasty milk in with some good milk and let it dry out, it made cheese, yogurt, and a bunch of things we were making with microorganisms. We didn't know they were coming from microorganisms. And what's kind of sad, which is also pretty typical, we went hundreds of years when we could have known what was killing us because somebody had developed the microscope. Okay, it will be in the 1600s we had developed the compound microscope, And again, we're another 1,700, another 100 years, and we still haven't realized that little beasties are killing us. We know they're there. We're making microscopes. More and more people are using them, but nobody is making the connection between the two. So this is a perennial problem with science. Until we develop some kind of machine that makes the thing that we're studying visible to us or sensible to our senses, it remains very, very speculative. So when we talk about the center of the sun is 10 million degrees, well, how do we know that? You stop and ask the question. That's what epistemology is, by the way, which is what we're studying. How do we know what we know? Well, we find out that that's a deduction. We can measure the temperature of a certain area of the surface of the sun. We can do that by, you see those heat sensors, you take some temperatures without touching somebody, or something like that. We can get the temperature of the surface of the sun. That's pretty much a direct measurement, although we're 93 million miles away. It's a pretty good measurement. So how do we know the centers, which is about, less than 10,000 degrees on the surface, something like that. And then what we do is you do the inverse square law, and we take that area in the sun and we squeeze it down to the center of the sun, and we compress the heat, and we come up with some number that the sun is so many millions of degrees in the core. Now, that's still not a direct measurement. This is, first of all, we can directly measure the surface. We can do the inverse square law, and mathematics takes us to the center, which is considerably more than the surface. We like those numbers. They're probably accurate numbers, but my point is, it's really not hard science when you say, center of the sun this, or the center of the earth that. Or if you say something like, dinosaurs died out 60 million years ago, and because we don't have an instrument to make the death of the dinosaurs sensible to us, so that we actually can see the last dinosaur dying. We would have to have what? You tell me. What kind of scientific instrument would we have to develop in order to make the statement 60 million years ago the last dinosaur died out? What kind of machine would we have to verify that empirically by our senses? Well, we'd have to have a time machine, and to my knowledge, those haven't been developed yet, ergo, that's a soft science as well. We can't actually go there. We talk about the brain and what it's doing, a schizophrenic brain, yada, yada, yada. Again, when we try to go into the brain with our instruments, we damage the brain, and by the time we get in there, the brain is not normal, or the person's dead. So things about the mind. This is what makes modern psychology a very soft science. We are speculating and looking at indirect things, responses, and thinking backwards about what might be happening inside the mind. So to repeat, one of the limitations of science is this: it is limited, hard science, because there's knowledge science, which the center of the sun is 10 million degrees. That's knowledge it's based on. But it's not hard science, because we're using deduction and we're making guesses about it based on what we can see. That germs cause us to have typhoid, that, again, until we have a microscope, that's pure speculation. In fact, no one speculated that I know of. So limitation of science. Hard science it can only deal with things that can be examined or made apparent to our senses. That's the first limit. So you should identify, if you're in general life, you hear statements on news or radio, you must ask yourself, could anyone have gone to the center of the earth and stuck a thermometer? Could anyone have traveled to the center of the sun, opened up the window and stuck the thermometer in the middle of the sun and gotten a measurement on it? And those two examples, like, if it's not possible, no one's been there, so it's soft science. Is it true? Maybe. You can look at their process and determine how strongly you want to believe it, but there's always things that we don't know about that can interfere with it and give us a completely different answer from what seems logical. I'll give you an example of that. When I was a child, we had a golden book encyclopedias, and I used to like planets, and I read through the planet section. And I remember very vividly. I think I still have the book in my library behind me someplace, but I'm not going to bother looking for it right now. But I remember seeing a artist's conception of what it looked like on Uranus. And what they did was the Earth, they knew how far the sun was from the Earth, and they knew how big the sun looked from the surface of the Earth. They also knew how far Uranus was away. So they took the sun and they reduced its size based on how far away Uranus was. They also reduced the light intensity. So what you have is this rock cliff. You see the sun reduced to its proper size, and everything is like twilight because Uranus is so far from the sun. And that was the picture. Well, as it turns out, that was completely wrong. Although it was deductively sound, it made sense. It was mathematically sound. We had good reasoning behind it. We find out later that Uranus doesn't even have a surface. It's a gas planet. So this is true all along the realm of science. Soft sciences may sound good, and they may have good, hard reasoning, deduction, logical processes, but there's always something that can throw a wrench in it, some additional information that we're not privy to, and it makes our conclusions completely wrong. Hard science has less of a problem with this, although even that has some problems. We'll deal with that shortly. So the second limitation of science is about a certain kind of statement we make. It's very, very common for scientists to make. It's called a universal negative. A universal no. Now, this is a problem for some people, and I don't know why. The last time I taught it in my class, I think I finally got through to most of the kids in the class, so we'll try to do it that same way. A universal negative is a kind of statement. It's a kind of statement. It's a statement that denies the existence of something. It doesn't exist anywhere. So this is why we call it a negative, because we're saying it doesn't exist, and we're calling it universal because we're saying not only doesn't it exist in front of my face, it doesn't exist anywhere in the universe. So that's the definition of a universal negative. Now, the most famous universal negative is there is no God. So we'll come back to that in a minute. To illustrate the problems and the kind of the knowledge structure that a universal negative has, there's two things that we know about universal negatives. One is they cannot be proved true. There's no way to prove there is no God. You can't prove it. Okay? There's no Loch Ness Monster, which I'm going to use that as an illustration. Just the Loch Ness Monster doesn't exist. That's a universal negative. You can never prove that. Now, you can potentially disprove the statement. There is no Loch Ness monsters. There is no God. So how you can disprove the negative is by producing God or by producing the Loch Ness monster. Aha! There is a Loch Ness monster. You've proven it wrong. The statement, there is no Loch Ness monster, you can potentially prove it wrong by producing the thing that's in denial. Those are two things you have to know. You can never prove any universal negative. It's simply not possible. Now let's explain why. I like the Loch Ness monster just because I'm Scottish descent, and it's an interesting kind of thing here, the Loch Ness monster. So what you have is a picture here is a satellite picture from space, which is what a satellite is, and we're looking down on Scotland in the winter. Now, the loch where the Loch Ness monster is supposed to exist is visible from space. It's this line, and basically, this is all granite. This is a big chunk of granite. This is Scotland, by the way. I don't know if you can see how far down this goes. I don't think you can see even a piece of England, but this is the lowlands and this is the highlands of Scotland. Maybe England's right here. I'm not sure. It doesn't matter. This is Scotland. And what's happened is this, at some point in history, this big chunk of granite broke right down the middle here. Nice straight line. You can see it. I've driven along the thing. Very, very straight, about a mile across. It varies, but it's very, very deep because a big crack just kind of went like this and cracking at a very deep thing. And then ocean water, I guess, initially flooded in, but there's quite a bit of rain up in Scotland. So as it rains and the snow melt and all that, it pushed the salt water out. And so what you end up with is a long lake, which is what in Scottish what they call a loch, and just say loch. And that just means a lake. So this is Loch Ness. So we know how the story of Loch Ness began a long time ago, back in Middle Ages. I just had a change in the light there. I'm not sure what the camera did. All right, there we go. I don't know exactly, but something like this. So a little bit of this is made up, but it gives you the idea of how this thing started. The idea of a Loch Ness monster. So you got a bunch of monks up there in the Middle Ages sometime, and they're getting bored. And so, but every once in a while, a bunch of rich Englishmen will come up and they want to go hunting or something. And there's no hotels up there in the 1400s or so. So they stay in the monasteries. And the monks like this because they get a little money, because the rich English guys pay them, and they get to have some company, swap some stories and all that kind of stuff. And so they're sitting around, I imagine they're sitting around at a table at night, and the Englishmen have been out all day, hunting, whatever. And they come back, and the monks have prepared them a meal, and they're all sitting around the table. So back then, with no phones, no TVs, no radios, you were expected to have a story in your back pocket to share. You had to have a good story. We used to do that as kids. Again, when I was a kid, we had no internet. So we'd camp out or something, or somebody would have a sleepover or something, and after you've eat your popcorn, you have to tell a story. You usually tell ghost stories or something. Everybody sits around, telling the story. So this is how we think the Loch Ness monster story began. So you have this priest. He's up there and he goes, "Well, lads, let me tell you something. Me and Brother McFergus, we were out on the loch." And remember, this monastery's out near the loch. He says, "And we were a-fishing. And one night we hear the thrashing of the water and this loud roaring noise. And I look around and there's a big beast with its mouth gaping open with teeth the size of me front arm, I tell you.